Okay, this is a simple theoretical question that we have here, which says wave mechanical model of the atom depends upon de Broglie concept of dual nature of electron, Heisenberg's uncertainty principle, Schrodinger wave equation, and D option says all, right? So we know what is the wave mechanical model of the atom. We say that, okay, we can't think of an electron, which is a very low mass object that is moving with high speed, right? So we can't consider it purely as a particle. We will have to consider the de Broglie duality in nature of an electron which is there within an atom. So yes, wave mechanical model of the atom has its foundations from this idea that every particle has a duality in it. There is not just particle behavior, there is also wave-like behavior when it has some kind of momentum, right? Then Heisenberg's uncertainty principle says that you can't exactly and simultaneously measure both position and momentum of a particle. Particularly when we have a very light subatomic level particle like electron, this becomes more and more important and relevant. So, based on these, Schrodinger kind of came up with the wave mechanical equation, right? So Schrodinger wave equation minus h square upon 8 pi square m del square psi by del x square plus E psi is equal to V psi. So whatever, I mean, we are not concerned about the Schrodinger equation, but yeah, we know that as far as the wave mechanical model of the atom, where we speak about what you call as orbitals, where we speak about these regions where there is a high probability of finding an electron, not an exact location that I know or an exact path that I know, that comes up from solving our Schrodinger wave equation, right? That gives us what you call as wave function psi, which is what you call as which is called the wave function of this electron wave, right? And we say that psi square is probability density, probability per unit volume. Based on that, psi square into dV will give us the small probability of finding an electron at this small volume dV, and we find out those regions where we can say that, okay, there is a 90 to 95% probability of finding my electron in this region, then we call it as an orbital and all. But yeah, obviously the exact place and all, exact orbital and all is like found out on the basis of Schrodinger wave equation. But the idea is that it is very, very, very fundamental to our procedure here, our methodology here, that we have to consider Heisenberg's uncertainty principle, that we can't exactly and accurately locate an electron, and also the fact that there is a dual nature in electron. Both of these were also a consideration that was part of this. So yeah, simple. All of these are important for our understanding of wave mechanical model of the atom. So wave mechanical model depends on all of these. So our final answer is D option. What is given is 11.6 grams of an organic compound having a formula of CnH2n plus 2 is burnt in excess of oxygen initially taken in a 22.4 liter steel vessel. Okay, this is interesting. 22.4, we are happy about this number because we know under STP condition 1 mole occupies 22.4 liters. Before the reaction, the gaseous mixture was at 273 Kelvin. Okay, that is also good for us, with a pressure reading of 2 atmosphere. Not very good for us. 1 atmosphere would have been very nice. 1 mole would have been the number of moles, but yeah, here 2 atmosphere. We'll see. After complete combustion and loss of considerable amount of heat, the mixture of the product and excess of oxygen had a temperature of 546 Kelvin and 4.6 atmosphere pressure, right? The formula of the organic compound is. Okay, cool. So let's look at a few things out here first of all. So you have 11.6 grams of an organic compound having formula CnH2n plus 2. 11.6 divided by molar mass should give me number of moles. If I know molar mass, the organic compound is obvious to find, right? I mean, the moment I get molar mass, I'll write 12n plus 2n plus 2 into 1 or 14n plus 2 should be equal to molar mass. I'll get n. My question is solved, right? So yeah, I don't know what is molar mass, but whatever. Is burnt in excess of oxygen, right? And 22.4 liter vessel is what we have. Original pressure was 2 atmosphere at 273, right? So 2 atmosphere, 22.4 liter is what I had at 273 Kelvin. Let's say, keeping it at 273 Kelvin, I convert the pressure to 1 atmosphere, right? Then what will happen to volume? Think about this. Volume would have been double, right? If I keep isothermal condition, P1 V1 should be equal to V2 V2. If I reduce pressure by half, volume should become double. So it should have been 44.8 liters. Why am I doing this? Because at 1 atmosphere and 273 Kelvin, 44.8 liters is actually occupied by what? 2 moles. So total number of initial moles, I can say N initial total, right? Total was equal to 2. So we started with 2 moles in all, in which 11.6 gram is that of your organic compound, and the remaining number of moles will be that of obviously oxygen, right? Now let's write down the reaction. So you have CnH2n plus 2 as your organic compound, and obviously now this is what alkane, right? CnH2n plus 2 would specifically mean alkane. Yeah. So CnH2n plus 2 plus O2 giving you general reaction. We know on complete combustion it will give me CO2 plus H2O, right? So N carbon is there, so I'm writing NCO2. 2N plus 2 hydrogen is there, so I'm writing N plus 1 H2, right? So N plus 1 into 2 is 2N plus 2, so N plus 1 H2. Now think about the total oxygen that are there. So I have N into 2, 2N here, and N plus 1 out here. So in all I have 3N plus 1 oxygen atoms on this side. So obviously 3N plus 1 atom should be on the other side as well. So I'm going to write here 3N plus 1 divided by 2. Right. So this is my balanced reaction, CnH2n plus 2 plus 3n plus 1 divided by 2 O2. Why did I divide by 2? Because O2, right? So 2 into coefficient will be total number of atoms. We wanted it to be 3n plus 1, which I am seeing on the right side. So yeah, this is what I have. Same reason why I wrote n plus 1 here. So n plus 1 into 2 will give me 2n plus 2, which is there on the left side, right? So this is my balanced reaction. At time t equal to 0, I don't know. Let's say you have some x moles of this. So obviously oxygen would have been 2 minus x, right? Because the two combined, I mean this is a organic compound plus oxygen combined, we know that the initial moles would have been 2, right? So obviously if there are x moles of this hydrocarbon, there will be 2 minus x moles of oxygen, and obviously initially there is no CO2, there is no H2O. Let's look at the temperature. Is it given? Yeah, so 273, and finally it is 546 Kelvin, right? So 546 Kelvin is double of 273, right? So 273 degrees C is what you have. Obviously water will also be in steam form here, right? So I need to consider water also out here. Now cool, what else? As far as this vessel thingy is concerned, the only thing that is fixed about this vessel is volume. Do you understand this? Number of moles is changing, pressure is changing, temperature is changing. The only thing that is constant for this vessel is volume. So what we write is PV equal to nRT. So take all the constants to one side and others to the other side. What we are going to get is V is equal to V by R is equal to NT by P, or you can say P by NT will be equal to R by V, which is going to be a constant for this vessel, right? I hope you understand what I wrote here. Whenever you have these gaseous state-based questions, see what is it that is constant, and can you use ideal gas equation to find some relation, right? So what I am seeing here is that P by NT should be a constant for this vessel, because its volume is fixed. R is anyways universal gas constant is fixed. So for that vessel alone, I can say that okay, P by NT should be a constant, which means P1 by N1 T1 should be equal to P2 by N2 T2. Right? I know T1, T2, I know P1, P2, I know N1, I can find N2. This is the idea, right? So what do I see here? I mean, this oxygen was given to us already to be in excess. So this is going to be entirely consumed. So this is time t equal to 0, some time t equal to t. This will be completely used up, and 1 mole of this is combining with 3n plus 1 by 2. So X will combine with how much? Basic common unitary method, you can say 3n plus 1 by 2 into X, right? So 3n plus 1 by 2 times X will be the number of moles of your oxygen that is consumed. So 2 minus X was the original, minus this will be what is left behind, right? This is going to be the number of moles of oxygen that is left behind. And as far as CO2 is concerned, I can see 1 mole is giving me n moles. So I just have to multiply by n. So I'm going to get nx moles of CO2 and n plus 1. 1 mole is giving me n plus 1 H2O. So x moles will give me x into n plus 1. So n plus 1 into x. This is the number of moles of H2O that is there, right? Now, coming back to this P by NT, right? So we said that P by NT is R by V, which should be a constant for this vessel. So P1 by N1 T1 is P2 by N2 T2. So pressure, initial pressure was 2 atmosphere, right? So 2, I'm using this and I'm writing 2 by number of moles originally was 2 into 273 Kelvin was original temperature, should be equal to P final is given to us as 4.6. So 4.6 divided by final number of moles, I don't know. What is this N2? This N2 is sum of oxygen remaining plus all the products combined, right? So 4.6 by N2 into T2 was 546, right? So this is pretty easy. What we can see here is that N2 will become equal to N2 is equal to 4.6 by 2, which is 2.3. Right, so I finally have 2.3 moles in this particular gaseous system, right? So from here I need to find the value of n basically, right? So I had, yeah, so what I can write is that sum of these final number of moles, all of these combined should be equal to 2.3, right? Maybe from there I should be getting some relationship for n. Do I get something about x? Maybe, let's see, right? So cool. So what do I get? I'm getting 2 minus x was the original moles of O2 minus 3n plus 1 by 2 times x was the number of moles of oxygen consumed, and nx is the number of moles of carbon dioxide, and n plus 1x is the number of moles of H2O. All of these combined, it should be 2.3. From here, what I can see is, okay, 2 minus x, okay, this is also a subtraction, then you have two additions here, right? So let me see, 2 minus x, let me open it up. What I'm going to get is 3nx by 2 minus x by 2 plus nx plus nx plus x is equal to 2.3, right? So let me take this out. I'm going to get 0.3 remaining, right? What do I see here? Okay, I'm seeing nx plus nx, 2nx minus 3nx by 2, right? 2nx minus 3nx by 2 is one term I can see here. Then what else is there? In pure x, I am seeing 1x here, minus x here. Let me cancel them out. Then I'm getting 1 minus x by 2. Right, this is the only thing that is remaining. I've taken this, I've taken these. So yeah, this is what I'm getting. This should be equal to 0.3, right? So what does it tell you? To 4nx minus 3nx will be nx. So nx by 2 minus x by 2 is equal to 0.3, right? So what does that tell me? N minus 1x is equal to n minus 1x is equal to 2 into 0.3 or 0.6. See, what is x? We said that x is the number of moles of our substance, right? X was the number of moles of hydrocarbon that we had taken, right? So we can speak about x in terms of n now, right? So what did I get? I got n minus 1 is x is equal to 0.6. Now what I'm going to do is, I'll say that x is equal to number of moles of hydrocarbon, which is going to be equal to 11.6 divided by, think about this, 11.6 is the mass of hydrocarbon. And your molar mass is going to be how much? 12n plus 2n plus 2, which means it is 14n plus 2, right? This is the molar mass, right? So 11.6 divided by 14n plus 2 should have been the value of your x, right? So x, okay. So from here, what do I see? I can substitute this here. Instead of x, I can substitute this here. So I should be able to get a new relationship. Do I have space somewhere? Yeah, this looks okay. Okay, not much space here. Okay, I'm going to erase this a bit to make a little space. right? So what we are getting is x as 11.6 divided by 14 and plus 2, right? X as 11.6 divided by 14 and plus 2, and yeah, n minus 1 into x is equal to 0.6. This is what I'm going to substitute. So what will I get? N minus 1 into, instead of x, I am writing it as 11.6 by 14 and plus 2, and this should be equal to 0.6, right? N minus 1 x is equal to 0.6. Let's cross multiply. What do you get? N minus 1 into 11.6. So 11.6 n minus 11.6 is equal to 0.6 into 14, right? 60 plus 24, 84, 8.4 n plus 1.2. 2 into 0.6 is 1.2. Now let's take these to the other side. What will I get? 11.6 minus 8.4 is what? 3.2, right? So 3.2 n is equal to 11.6 plus 1.2 is 12.8. Wow. Which means that n is equal to 12.8 by 3.2, which is equal to 4, right? So we got the value of n also. Now what did we have to find out? What is the hydrocarbon? Obviously, what is the hydrocarbon? CnH2n plus 2, C4H10, right? So our final answer is D option. Okay, this is a simple question here. In which of the following sets the central atom of each member involves sp3 hybridization, right? So when we are looking at sp3 hybridization, we want all of them to have a steric number equal to 4, right? When steric number is 4, we get hybridization to be sp3. And what is steric number? Steric number is supposed to be equal to half of your number of monovalent atoms plus valence shell electrons minus charge, right? So when I'm looking at all of these one by one, let's calculate steric numbers. In IO4 minus, number of monovalent atoms, obviously central atom is iodine, valence shell electrons is 7. So here I'm going to get half of valence shell electrons is 7 for iodine. Monovalent atoms we don't have, we have oxygen, right? So oxygen is divalent, so plus 0 minus charge is minus 1, so minus 1 is plus 1, right? So 7 plus 1 by 2 or 8 by 2 is what we get. So this is 4. So in IO4 minus we have sp3 hybridization. ICl4 minus, let's see. So here half of iodine is the central atom, 7 plus monovalent atoms, you have your the 4 chlorine atoms, all of them are monovalent, so obviously 4, and minus charge is minus 1, so minus plus 1, so this is 7 plus 5, 12 by 2, which is 6. So this is ICl4 minus is not sp3, it is sp3d2. That tells me I can discard this already, but let's do it for IF4 plus as well. It will become half of iodine, again central atom, valence shell electrons is 7, monovalent atoms 4 fluorine atoms, charge is plus 1, so 7 plus 3, 10 by 2, 5, right? So this is sp3d, right? So yeah, all of them are sp3, of course not, right? XeO3, what will it be? Half of, let's do it here, half of valence shell electrons, xenon, right? Noble gas, 8 electrons will be there, no monovalent atom, so plus 0, no charge is there, so minus 0, divided by 2 means 4, which means this is sp3, right? This works for us. XeO4, same story, right? So half of 8, because there is no monovalent atom, there is no charge, so you plus 0 minus 0 divided by 2, this is also 4. In XeF4, what will it be? Half of 8 monovalent atoms, 4 fluorine atoms are monovalent, there is no charge, so this is 6 by 2, right? No, 12 by 2, which is 6, which means sp3d2. Yeah, again this is not our right answer. XeO3, XeO4 will work for us, but yeah, XeF4 does not work for us. In the next one, what do you see? SO3 sulfur, oxygen family, 6 valence shell electrons, half of 6 plus 0, no monovalent atoms, only oxygen, minus no charge, so this is 6 by 2, which is 3, sp2, we know, right? Sulfur dioxide is sp2, right? So this is obviously not going to be our answer, because already we know we want all of them to be sp3. The first one itself is sp2, but yeah, whatever. Let's see next one. SO3 2 minus, I'm going to get half of valence shell electron 6, monovalent atom 0, charge is minus 2, so minus is plus 2. So yeah, SO3 2 minus, I'm going to get steric number 4, sp3 will do. SO4 2 minus, same story, half of 6 plus 0 minus minus is plus 2. So yeah, this is also 4. So SO3 2 minus, SO4 2 minus are sp3 hybridization, but SO3 is sp2. So this is also not our answer. Obviously it had to be the final one, but let's still calculate. Half of phosphorus is the central atom in PCl4 plus. Phosphorus has 5 valence shell electrons just like nitrogen, plus 4 monovalent chlorine atoms are there. Plus 1 is the charge, so minus 1 will be what we do here. So 5 plus 3 is 8 by 2 is obviously 4, right? So this is sp3. Bf4 minus, let's think about this. Boron, right? You have valence shell electrons 3, right? Boron is atomic number 5, 1s2, 2s2, 2p1. Half of 3. And you have 4 fluorine atoms, all of them are monovalent, so plus 4. Minus 1 would be plus 1, right? So this is 8 by 2, which is also equal to 4, which means this is also sp3. We already knew, had to be, but yeah, whatever. Last one is ClO4 minus. Half of chlorine is halogen, so 7 valence shell electrons, no monovalent atoms, only oxygen, and charge is minus 1, so minus minus is plus 1, right? So 7 plus 1 by 2 is again 4, which means yeah, in this even the last one is also sp3, right? So PCl4 plus, BF4 minus, ClO4 minus is where all of them are steric number 4, which means all of them are sp3. So our final answer is of course D option. Okay, this question says an indicator has pKin is equal to 5.3. In a certain solution, the indicator is found to be 20% ionized. Calculate the pH of the solution, right? So what do we have here? We have, let's say, acid indicator HIN. This is going to give us IN minus and H plus. So H plus plus IN minus. When we speak about indicator constant KIN will be equal to H plus into IN minus divided by HIN. I am writing it like this. Why? We will see very soon. When we take negative log on both sides, I am going to get negative log KIN, which is pKin, is equal to negative log H plus. Log of A into B is log A plus log B. So negative log H plus and negative log IN minus upon HIN is what I am going to get. Negative log H plus is pH and negative log of IN minus upon HIN. Right? This is the expression relating pH and your pKin. pKin is already given to us as 5.3, right? Now, this IN minus upon HIN, let's see. What is said is that the indicator is 20% ionized, right? So, if I am considering, let me write this equation a bit to the right so that it's a bit more clearer. So, yeah, if I have HIN, it is dissociating to give me H plus plus IN minus, right? So C into 1 minus alpha, C alpha, C alpha. We have heard of all of these, right? So alpha here is 0.2. 20% ionization is there. So let's say time t equal to 0 concentration was some A molar and these were not there. And when there is ionization, time t equal to T, so it should become 20% is ionized, so 80% is left. So you will get 0.8 A. And from 1 HIN, I'm getting 1 IN minus. So 0.2 A is what dissociated, alpha. C alpha is dissociating, right? So generally that is what we say. C was initial, C into 1 minus alpha is final because C alpha dissociated, right? So 0.2 A is what dissociated. So 0.2 A is what I'm going to get for IN minus. So 5.3 is equal to pH minus log of IN minus. See, concentration ratio is same as number of moles ratio. It's the same solution, right? So number of moles of IN minus divided by volume is concentration of IN minus. Number of moles of HIN divided by volume is concentration of HIN. So these will cancel out. So number of moles ratio is same as concentration ratio. So yeah, 0.2A divided by 0.8A. AA will cancel. 0.2 and 0.8 would mean 4, right? So minus log of 1 by 4. So if I take it to the other side, I'm going to get pH is equal to 5.3 plus log of 1 by 4. And plus log 1 by 4. Log of 1 by x is minus log x. So I can write this also as minus log 4. And what do I know about log 4? Log 2 is 0.3. So log 4 is what? Log 4 means log of 2 square, which means log of x to power y is y log x. So log 4 is going to be 2 log 2. So log 2 is 0.3, right? So log 4 is going to be 2 log 2, which is 0.6. So yeah, 5.3 minus 0.6 is how much? 4.7. Right? So yeah, looking at the options, the correct answer here is the pH of the solution. If the indicator is 20% ionized, will be 4.7, option D. It's an interesting question. It says The solubility product of AgCl at 25 degrees C is 1 into 10 to the power minus 10. Okay. A solution of Ag plus at a concentration of 4 into 10 to the power minus 3 molar just fails to yield a precipitate of AgCl with a concentration of 10 to the power minus 3 molar of Cl minus when the concentration of ammonia in the solution is 2 into 10 to the power minus 2 molar. Right. So what do we have here? We have what you call as increase in solubility of a sparingly soluble salt due to complex formation, which is the reason why, like if you see here, the concentration, what is the dissociation equation here? We have AgCl giving us Ag plus plus Cl minus. This is my sparingly soluble salt. QSP, the ionic product under given concentrations originally should have been concentration of Ag plus into concentration of Cl minus. This should have been 4 into 10 to the power minus 6, which is way greater than this 10 to the power minus 10. So why is it not precipitating here? Right? Precipitation is not happening because of complex formation. What is happening is that this Ag plus is disappearing. This Ag plus is disappearing with ammonia as your complex. So this is the reason why we are seeing that precipitation is not taking place, right? So what is happening here is that you originally had a 4 into 10 to the power minus 3 molar Ag plus, you had originally 10 to the power minus 3 molar Cl minus, you had some concentration ammonia solution, and some of this Ag plus, I mean more or less all of this Ag plus is reacting with ammonia and converting into, say, the complex, and that is the reason why Ag plus concentration is not really that high, and you are seeing that the precipitation is just avoided. Now when you hear this term precipitation is just avoided, what you should understand is that Ag plus into Cl minus should be equal to Ksp, right? This is the case where ionic product is exactly equal to your solubility product, and at that point you say that no precipitation will take place. If Ag plus was more than this or Cl plus was more than this, what is there currently, then yeah, ionic product would have been greater than solubility product. We would have said precipitation should take place. But yeah, here specifically they have said that no precipitation. In fact, precipitation is just failed, right? So precipitation is just avoided by this, which means that I can say that Ag plus is much lower. Now, as far as Cl minus is concerned, it is going nowhere. Cl minus is going nowhere, which means that Cl minus concentration I am sure is 10 to the power minus 3. Ksv is given to us as 10 to the power minus 10, which means obviously Ag plus has to be what? Ag plus will be Ksp by Cl minus. So 10 to the power minus 10 divided by 10 to the power minus 3, which means 10 to the power minus 7 molar. So the thing is, as far as Ag plus is concerned, we had 4 into 10 to the power minus 3, but it is not 4 into 10 to the power minus 3 anymore. It is becoming 10 to the power minus 7. Now think about this. What is happening here? Ag plus 2NH3 giving you Ag NH3 whole twice plus silver amine complex formation is happening here. So at time t equal to 0, you had 4 into 10 to the power minus 3 molar of Ag plus. Do we know about ammonia initial concentration? No. What is given to us is that when the concentration of ammonia in the solution is 10 to the power minus 2 into 10 to the power minus 2. So the final concentration of ammonia is known to us. It was some C. Let's say initially it was some C. But final concentration time t equal to t, I know that Ag plus has become 10 to the power minus 7. How? Because we just said that precipitation is just avoided. So Ag plus into Cl minus should be Ksp. Cl minus is going nowhere, no complex, nothing is happening. So Cl minus is still 10 to the power minus 3. So Ag plus has to be 10 to the power minus 7. And this ammonia concentration at equilibrium is given to us as 2 into 10 to the power minus 2. And obviously complex wasn't there initially. So I can say, now think about this. If let's say, okay, I know that this is 10 to the power minus 7, but let me just write it as 4 into 10 to the power minus 3 minus x, which is equal to 10 to the power minus 7. Say x moles per liter of Ag plus dissolved, right? So it should have been this 2 into 10 to the power minus 2 is actually C minus 2x, right? So some initial concentration of ammonia was there. 2x out of that. If x moles per liter of Ag plus reacts, double the number of moles of ammonia will react per liter. So if x molar is the reduction in Ag plus, then 2x molar is the reduction in ammonia. But yeah, whatever. The final concentration of ammonia is given to us as 2 into 10 to the power minus 2. Now, obviously, 1 Ag plus is giving me 1 mole of this complex, right? 1 Ag plus is giving me 1 complex ion. So, obviously, X moles per liter is going to give me X moles per liter of this complex ion, right? So, final concentration of silver amine complex AgNS3 whole 2s plus is X molar. Now, look at this. 4 into 10 to the power minus 3 minus X is equal to 10 to the power minus 7, which means X is equal to 4 into 10 to the power minus 3 minus 10 to the power minus 7. Think about this. This 10 to the power minus 7 is almost what, 40,000 times smaller than this 4 into 10 to the power minus 3. So this is approximately 4 into 10 to the power minus 3 only, right? So obviously 4 into 10 to the power minus 3 approximately, which means silver amine complex also I got it as X, which is 4 into 10 to the power minus 3, right? Now, do we have all the terms that we need out here? Yes, we can easily calculate the K equilibrium for that given reaction, right? So let's see. This was the reaction given to us. So what will we say about the K equilibrium? K equilibrium should be equal to Ag plus concentration into ammonia concentration square divided by complex concentration, right? So do I know Ag plus concentration? Yes, I know Ag plus concentration is 10 to the power minus 7. Final concentration is 10 to the power minus 7. So 10 to the power minus 7 into, do I know ammonia concentration? Yes, final ammonia concentration in that solution they said is 2 into 10 to the power minus 2. So 2 into 10 to the power minus 2 whole square is that of ammonia square divided by X is going to be, divided by complex concentration is what I need. Complex concentration we got it as 4 into 10 to the power minus 3. So divided by 4 into 10 to the power minus 3. What will I get? Okay, this is 10 to the power minus 7 into 4 into 10 to the power minus 4 divided by 4 into 10 to the power minus 3. So 4 will cancel. 10 to the power minus 11 divided by 10 to the power minus 3 is what? 10 to the power minus 8. So yeah, we are getting the equilibrium constant for the given reaction. Although this is not the reaction that is happening. Understand that the reverse reaction is what is happening. But yeah, since we are asked the equilibrium constant for this reaction, we got it to be 10 to the power minus 8, which is obviously there in A option.